Hello everyone, myself Pooja Devi from Department of Physics and Astrophysics, University of Delhi. I am going to represent preparation and characterizations of electrode materials COV Argeo nanocomposites for supercapacitor applications. First we will discuss about what is the difference between the capacitor and supercapacitor. So basically capacitor is made up of two conductors separated by a dielectric, makes use of produced EMF on applying voltage to store charge. Their capacitance value lies between the 1 picofarad to 1 millifarad. So in supercapacitor consists of two electrodes separated by a separator and electrolyte connected between both the electrodes, makes use of thin dielectric between a high capacitance than conventional capacitors, usually in farads, high energy density. So in next slides, first we will discuss about the supercapacitor. So supercapacitor basically divided into three categories. The first one is EDLC, the second one is the hybrid capacitor, and the third one is the pseudo capacitor. So EDLC is, what is EDLC? EDLC is the electric double layer capacitors. So hybrid capacitor is basically combination of these two, and the pseudo capacitor is basically divided metal oxide and the conducting polymers. So application of supercapacitor is used in consumer electronics, voltage stabilizers, uninterrupted power supply UPS, we can say, energy harvesting, street lights, military, railways, light rails, buses. And this is our present work. I'm basically going on preparation and characterization of COV-RGO nanocomposites and its electrochemical performance for supercapacitor device application. This is our methods, how we prepare our materials. So first one is COCl2.6H2O plus NaVO3 is combined, then add liquid ammonia for 180 degrees Celsius for 24 hours, then hydrothermal reactions is used, and this is our setup, and this is the cyclic voltammetry, and basically this is the charging discharging behavior of our materials. So this is the electrode we have prepared. So these are two characterization. The first one is the XRD and the second one is the FESEM analysis. From XRD, this behavior is shows cubic phases, and FESEM shows the morphology of our materials. So this is our work. First, in the first diagram A, the cyclic voltammetry of these three materials CO3, V2O8, RGO and composite, means you can say pure RGO and composite. You can easily see the difference between these two. The second one is the cyclic voltammetry at different scan rate, and the third one is the charging discharging behavior of the our materials at different current density. So this is the cyclic voltammetry and charging discharging behavior of a RGO. And from this diagram you can easily see the first one diagram shows for composite materials. This is we are basically working on the device. So this is the cyclic voltammetry for the device at a constant scan rate 50 millivolt per second and different voltage windows. And the second B diagram you can easily show that at different scan rate, this is the cyclic voltammetry. And the third one diagram you can see in C diagram, this is the charging discharging behavior of our material. And in diagram D you can see the GCD cyclic stability of the devices. So you can easily see the difference. So for RGO materials, the specific capacity is this, at current density is this, and this is for composite and this is for the devices. So you can easily see the difference. So this is the conclusions. So to synthesize this materials, hydrothermal is route basically used for this composite excellent specific capacity, and this is the conclusion of our material. Okay, thank you so much.